All right, welcome back to Everything Mathematics, and today we're going to continue our part two of two, when we're looking at calculating the gradient of a line. In yesterday's video, we look at the same picture we have in front here, how to calculate the gradient of a line when given 2 points. And that's basically looking at the rise over the run. Today, we are going to look at the second one. So this was yesterday, calculating the gradient of a line when given 2 coordinate points on the line. Today we're going to look at calculating the gradient of a line when given a line and the y-intercept. So that will be our part 2 of 2 videos. So the concept here is basically this. So you use the general form of the equation with everything given, and then you make m the subject of the formula. So that might sound like rocket science, but again, let's simplify. So you have, this is the general form of the equation, y is equal to mx plus c. And again, because you will be given y, which is the y-intercept, which is c, and you will also be given a coordinate for x, and you'll be given a coordinate for y. So let us say y is 2, let us say y is x is 3, and let us say c is 4. Look at that, 2, 3, 4. I didn't even pay attention to that. So you will be given all these. So at the end of the day, once you get all this, you're basically finding m. And that's basically all we're doing. So we'll end up with a scenario where we have 2 is equal to 3m plus 4. And from here, it's just a game of algebra to make m the subject of the formula. If you can't remember how to do this, then I could gladly attach to this video my series on algebra, where you could look at the specific video, whether it is transposing, cross multiplication, getting rid of multiplication or division, to make m the subject. So let's do some today. So here we have our first example. A line drawn cuts the y-axis at 4 and passes through the points 2 and 3. That's our coordinate points. So they're asking us what, but look at that. We literally just presented this. Oh my, this is pure coincidence, honestly, sorry. But yes, but here, this is basically the same scenario I just dropped there generically. So yes, so if we identify our values, remember, where the y-axis gets cut is known as our C, because that's the y-intercept. So our C here is 4. The point that passes through, that's the coordinate. So remember, for each coordinate, we always have an x and a y value. So our x value will be equal to 2, and our y value, according to the coordinates, will be equal to 3. Look at that, just like just noted. But now just know that we had 2 for y, I think. So with this now, we state the general equation of a line, which is y is equal to mx plus c. That's the general format of an equation of a line, and then we just substitute values. So we know y is given as 3, we don't know m, but we know x. So let me put it like this for now. X is 2, and we know that our c is 4. And m2, we generally put the unknown after, so this is the same as 2m, right? And from here, we just want to make m the subject. So I will go about by transposing this. So that will leave me with 3 minus 4 is equal to 2m. And when I find the difference here, I'm getting minus 1 is equal to 2m. And of course, I divide by 2. And I divide by 2 because I do it on one side to keep balance. I do it onto the other side. And that leaves us with the m, which is the gradient, equal to -1/2. Easy enough, right? And sometimes you might be asked to write the equation of that line. And if you were to do that, all you say now is y is equal to 1/2 x plus c. Well, we know c is 4, so we could put the 4. It's only the y and the x we do not put, because the y and the x is dependent on which point of the line you're referring to. So yeah, that's what we do, and that's it. Let's look at the second one, second and last one, I think. And here we have a different question. So a line drawn cuts the y-axis at -3 and passes through the points 3 and 5. What is the gradient of that line? So again, let's find the same concept. We have c is given as -3. We have x given as 3. And we have y given as 5. And if I go to solve that, again, I just said the general equation of my line. So y will be equal to mx plus c, and that's the same thing as y is 5 x is 3, so I put in my 3 first and then my m, and c, oh, c is negative 3, so I can't put plus there. C will be negative 3. Yep. And again, I solve for m. So when I send over this 3 over here, it's negative. When it go over, it will be positive. So that will leave me with 5 plus 3 is equal to 3m. That's the same as 8 is equal to 3m. And then I divide here by 3, and I divide here by 3. And I get a gradient of m. Remember, this 3 cancels this 3. So my gradient will be m is equal to 8 over 3. Which again, I guess in this case, we could simplify further, which will be 2 and 2 over 3. I guess we could do that. We don't have to, but we could. It's a gradient, so it doesn't matter. And sometimes, well, again, I could draw this line for perspective, but again, it doesn't serve a purpose in this case. So yes, that will be it for today. So that's basically how we find the gradient of a line, or another way in which we could find the gradient in the event that we do not get 2 coordinate points. We could use 1 point if given and find the y-intercept. And sometimes even if we're not given the y-intercept, we could try and locate it by graphing the equation or graphing the points, you know. That's all those things are possible and more. As a matter of fact, a lot is possible when you're graphing. You could get a lot of answers. It's one of the #1 most powerful ways, I would say, in solving mathematical equations. Yes, by trying to graph it, believe it or not. So yes, that will bring us to the end of today. Again, like, share, and subscribe. Feel free to leave a comment in the comment section below and turn on the notifications so that you'll get the next one tomorrow, God's willing, where we'll be starting our part 3 of 3. We'll be looking at part 1 of 3 videos, which will be addressing the relationship of linear equations. That's where we'll address parallel, perpendicular, and of course, concurrent lines. So until then, you take care. God bless.